Hello guys, welcome back. Now let's have a look over a new ADC, that is analog to digital converter, and it is MCP3428. And to search this sensor, let's roll upon the website, that is controleverything.com, and here we have to type in for the sensor for the ADC exactly, and it is MCP3428. And by searching it, let's see what we got here. As you notice, it's a 16-bit 4-channel analog to digital converter, and these are some more prominent features of this very ADC. And you can also purchase the sensor from this site right from here. Furthermore, in the interfacing part, we have the ADC MCP3428 with a BeagleBone Black, and the concerned platform will be, the software platform will be C code language. And to get your hands onto the code, let's go to resource tab, and here comes the C code sample, as you can notice, and click on it, and you can download the code sample as a zip file right from here. Also, you can get the code from github.com, and the concerned repository there is Control Everything Community. Now let's have a look over the hardware connections we need to set up together, and let's see what we got here. Well, for the hardware connection setup, the first thing we require is the BeagleBone Black, which you are able to see on my screen. And this here is an I2C Shield for the BeagleBone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what do we require is to gently place this I2C shield over the BeagleBone Black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this, and gently insert it over here. It is very useful to power up the BeagleBone Black. Now to power up the I2C Shield, we require a 5-volt adapter, which you are able to see on my screen, and gently inserted here. Now for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless nano USB adapter. Next, this here is our analog to digital converter, that is MCP3428, and this here is a connecting cable. Now make sure that while making a connection with the cable and the ADC, the brown wire of the cable should be connected to the ground terminal of the ADC, and similarly to the ground terminal of the I2C Shield. So these are the connections we required for this hardware. Now let's proceed with the code. Further, in the interfacing section, we have to first of all log into github.com, and here we have to search on for the repository, that is Control Everything Community. After getting it, we have this ADC, that is MCP3428, and let's proceed, and we have the C code. But let's have a look over the instructions part first. As you notice, we have to set up a BeagleBone Black according to the steps, and it's provided on BeagleBone.org. And let's open up this link, and you notice we have a lot of to do to set up this BeagleBone Black, as you notice. And after getting this setup, we have to download or pull the code onto BeagleBone Black. After that, this is the command for the compilation of C code, and this is to build or run the C code. Note them down, and we will use them later. After getting this, we have to get back to C code, and as you notice, it's a .c extension file. And first look, we have noticed that we have imported some of the header files, as you notice on my screen. And in the void main function, we have an integer, as you notice, we have file integer, and we have a function which will check whether the bus I2C bus is open or not. Then we have to check for the I2C device, and for the address of the sensor, that will be 0x68. Now in the writing section part, we have the select configuration command, that is 0x10, and we have continuous conversion mode channel 1 along with 12-bit of resolution, and it comprises of 0x10, and we have the write function here. Then we have a delay of 1 second, as you notice, sleep function here. Then we have to write 2 bytes of the data from the register, read 2 bytes of the data, that is from the register 0x00, and here it is, as you notice. And then we have to convert the data into 12 bits, and we have followed the same set of procedures described clearly in the datasheet of ADC, that is MCP3428. At the very end of our code, we have the output data to be displayed onto the screen, which is the digital value of analog input. So this is how the code is. Now let's look over how it works. Now coming to the very interesting part, which is the working, and here we have to check the practicality of the ADC and the code, and for that let's copy the entire code of this C, and here we have to open up the terminal. For the BeagleBone Black we have connected, and here we have to create a new file, and let's see what we got here, and we have to paste the entire code here, and then we have to save it. Now this command will check the compilation of the code we have just created, and then let's see what we got here, and the code is being compiled successfully. Now to build our code, this is the command, and let's see what we got here, and we have the digital value of analog input, and it is exactly value 0, which means nothing is connected, or either the terminals are connected to the ground terminal. But instead, when I try to connect a AA battery of 1.5 volt, which is the standard voltage of the cell, and run the command, we have the digital value of analog input, and it is exactly 1048. When I again run the command several times, the same value of very minute change is onto the screen, which means the sensor is responding well and a standard cell is connected at the ends. Now what we're gonna do is to show the applications and some of the workings features of this particular ADC. Let's have it. The MCP3428 is a low noise and high accuracy 16-bit delta sigma analog to digital converter, family member of MCP3428 series. This device can convert analog inputs to digital code with up to 16 bits of resolution. Due to high accuracy in analog conversions, the applications of this ADC are portable instrumentation and consumer goods, temperature sensing with RTD thermistor and thermocouple, brick sensing for pressure, strain and force, weigh scales and battery fuel gauges, factory automation equipment. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.